Hello, welcome back to Math with Patrick. Today's July 30th, and we're solving problem number 211 from the Daily Epsilon calendar. And we need to figure out why. The answer is 30 today. So we need to find the largest number, x, that is a factor of 5,250 and 1,260, that also satisfies this condition right here. This says that the greatest common divisor of x, and I'm assuming that says 1001, equals 1. It's a calendar, so this spot right here is punched out, so you could hang it on the wall. So a little bit hard to read that number, but I'm almost certain it's 1001. So I'm thinking, let's find some factors of these two numbers so that we can find a mutual or common factor between the two numbers. And I think we're also going to have to find some factors of 1001, because then or divisors, those are kind of synonymous, because then we'll need to know that x and 1001 do not share any common factors or divisors. So let's just get into it and see what happens. I'm going to make some factor trees for our important numbers for this problem. This one, I can see that we can divide into 250 and something. There's going to be 4 250s in every 1,000. So I'm just kind of counting up on my 250s right now. Since I have 5,000, I'm going to multiply this by 5 as well. And then the one more 250 makes 21, the right number to put here. And let's keep factoring. 25 to me is pretty clearly, 250 is pretty clearly 25 times 10. And then finally, I can break this up into 5 and 5, and then 5 and 2. And then this 21 is 3 times 7. And now I have found all the prime factors for 5,250. Let's do the same thing to 1,260. I think I'll also opt to just do 126 and a 10, break up the 10 into 2 and a 5. And then now we need to factor 126. I guess I could just split it in half. That's going to be 2 times, I think that's 63. 63 is a multiple of 9. That's going to be 9 times 7. 7 is another prime. And then finally, I didn't need to actually box that 63. There we go. I like to box or circle the prime numbers at the very bottom of my factor trees. And then finally, 9 is 3 times 3. And so now I've found all of the prime factors of 1,260. So I think for a sec, I'm going to ignore this last condition. And I just want to find what is the largest common factor between the two numbers. And to find this, I guess, let me see. So we have 1, 2 over here, and then 1, 3. We have 3 5s, which I'll represent by doing 5 cubed, and then 1, 7. So if I multiply up all of these numbers right here, I should get 5,250. And now over on this side, I have 2 2s, so 2 squared. I have 2 3s, 3 squared. And then I have 1 5 and 1 7. So times 5 times 7. So their greatest common factor is just going to be kind of a combination of these two prime factorizations, where I'm only allowed to take as many prime numbers as the lesser of the two. So for example, I have 2 over here and 2 times 2 over here. And to construct their greatest common factor, I'm only allowed to just pull the 1, 2. Same thing kind of goes with the 3s. I'm only allowed to pull the 1, 3. For the 5s, this number has more 5s, this number has fewer, and so I'm only going to pull this 1, 5. And then they happen to have the same number of 7s, it's just one of them. So I'll just pull 1, 7. And so it seems like the greatest common factor between these two numbers is essentially just the primes between 2 and 7 all multiplied together. That's 6, that's 30, and then this would be 210. However, the answer today isn't 210. We now need to consider this condition right here, where our number x also satisfies the condition that the greatest common divisor between x and 1001 is just 1. Or in other words, x and 1001 don't share any factors. So I need to factor 1001. I'm going to see what primes show up. And then I'm going to kind of cancel out any primes that show up in this number. Well, 1001 is clearly odd, so this 2 gets to stay. There's also a divisibility trick with 3s, where if you add up all the digits of the number, the sum that you get will have the same, or it'll be divisible by 3 if and only if your original number is divisible by 3. So since I noticed that the sum of this number is, or the digits of the number is 2, then I know that since 2 isn't divisible by 3, neither is 1001. So that means I should keep the 3 in my product here because this number doesn't have that as a divisor. It's also pretty clearly not divisible by 5 because this 1's digit isn't a 0 or a 5, so we get to keep the 5. And now I can see that these numbers all together make 30, and that's today's date. So I should just prove that 7 is a factor of 1001. And I don't have really any good divisibility tricks for 7s, so I'm just going to do it the nice classic way and do some long division. 7 goes into 10 once, or I mean, technically what I'm doing is 700 goes into 1001 once. And then I'll do 1 times 7, I'll subtract the 7, although again, technically it's like I'm subtracting a 700 out from my 1001. I'll get a 3. I'll drop down the 0. 7 goes into 30 4 times. 4 times 7 is 28. I'll subtract that, get a 2, bring down the 1, and then 7 goes into 21 evenly 3 times. And then I can just kind of show that by doing the subtraction here and getting a remainder of 0. So since 7 goes into 1001 evenly, that is a factor of the number. And since the greatest common divisor of our number x and 1001 has to be 1, that means that they don't share any other divisors besides the number 1. And so x cannot have the number 7 as a factor. So we can multiply 2, 3, and 5, get 30, and there is our answer for today. So I guess we're all done. Hope you enjoyed, and I'll see you tomorrow. Bye.